we started with point. Those are okay as far as naming and identifying. Capital printed letters, right? Line. All right, so with a line, can you ever name a line with 3 points with a line over it? No. And I get that kind of answer all the time. No. If you write something down and then you look at your notes and you don't have anything even remotely close to that written down, you're probably not doing it right. Okay? No 3 points with a line over it. It clearly says 2 points and a line over it, and then some of the examples. Yes, there's 3 points here, but I don't use all 3 of them. That doesn't make any sense. And then what you say, and of course you have to use the word line for the little italic letter. Okay? Collinear, I think we're okay on that, except that what I've seen, and I think I forgot to erase this. What I've seen a bunch, somebody came to me this morning with this, but it dawned on me that I see this all the time, and I'm quite sure it wasn't the only person that has done this. But this type of thing for 3 collinear points. No. All right? Again, that doesn't mean anything. That's just wrong. Also, 3 points means you name 3 points. It doesn't mean 3 sets of 3 points. If that's what it meant, that's what it would say. You with me on that? So make sure you're not reading too much into it and trying to do something it's not really asking you for. There's an example in your notes of that. Here it says points A, B, and C are collinear. So if you got to name 3 collinear points, this is how you name them, right? A, comma, B, comma, C. You actually just list them out. When you name a point, you can just put A, or if you want to put point A, that's fine too. I think putting the word point sometimes just makes people feel better, but it's okay either way. Plane. When you're naming a plane. So I kind of answered this question at the beginning, but I don't know that everybody heard me. So I can name a word, I name it with the word plane and 1 capital italic letter. That's only if it's actually there. If it's not there, I don't get to make one up. Does that make sense to you? Like if the R wasn't there, then I can't do it that way. Then the other option is the word plane and 3 non-collinear points. Now, I could name this plane ADB, and you could name it plane DCB. And somebody else can name it plane BAD. And all those they're all correct. And there's a lot of different correct answers. That's going to happen a lot in geometry, where there can be more than one right answer. So it's good that you work together, but before you end a friendship because you're arguing over who is right, you both may be right, okay? So, I mean, there's a lot of times where I have to walk around and be, okay, everybody calm down. We're very passionate about math, and that's exciting, but everybody could be right and be different. So, but remember, they have to be non-collinear, and we'll talk about why here in just a minute. Okay? Any questions on any of that so far? Maybe clear a little bit of stuff up. All right, so then we add line segment and ray, and I think that stuff was kind of okay on that. Just make sure, again, when you're answering the questions about this stuff on your homework, that you're looking at this and you're naming them correctly with the correct notation and stuff on top of them. Okay? Any questions about anything we went over yesterday? All right, so then you have today's in front of you. Put page 36 on the top of that, where it has the ISN page. Okay, so we are going to start with opposite rays. Oh, I'm sorry. Will you pass that behind you, please? All right, so we're going to start with opposite rays. Just by the name of what it is, what do you think is true about opposite rays? Well, it's not the opposite of a ray. It's just 2 rays that are opposite, basically. Now, that's not good enough. You can't, use the word opposite in there. And the word opposite is a little bit vague, so we have to be a little bit careful with that. But we're going to pretend like these have arrows on the end so that these would be 2 rays. Okay, so these 2 rays here, they're connected. Are they going in opposite directions? Okay, technically, no. But that's why the word opposite is kind of vague, because we could argue that maybe this is opposite. They are going in different directions. But this thing it creates when I have them snapped together like this and going in different directions, what is this thing that I have then? Don't overthink it. It's an easy question. It's an angle. Okay? So I have an angle. So 2 rays that have a common endpoint makes an angle. Yes? But they're not really opposite. This would really be more truly opposite. Right? What does this create? A line. Is it still an angle? Yes. What kind of angle is it? 180 degrees. It's also called starts with an S, not supplementary, not obtuse. Starts with an S. Straight angle. It's a straight. It's a thing. It's a straight angle. It's 180 degrees. Okay. So it does create a line. These are opposite rays. When you look at the picture that I know that you already have the picture there, it just looks like a line, right? So you've got that thing that looks like a line. That's because there's opposite rays in there. We'll talk a little bit more about the picture in just a minute. But it has more to do than it's not just about being in opposite directions. They have to have a common endpoint, and they will always form a line. And if you say form a line, then that for sure makes it go opposite, and we don't have to determine what does opposite really mean, okay? So our definition is two rays with a common endpoint and form a line. That's what opposite rays are. And then you have your picture already. So in this picture, it just looks like I drew a line and put some points on it, right? But this line, it is a line. There are rays that live in that line. There are segments. There are points. There are opposite rays there are rays that are not opposite rays. There's all kinds of things going on there. To distinguish between what's what, that's why the notation is so important. Because if I put BC down, well, I could use BC to name the line. I could use it to name a segment. I could use it to name a ray. Actually, I could use it to name two different rays, depending on how I did it. So all that notation there becomes important, right? But yeah, opposite rays will always just look like a line. But that has a whole lot of stuff going on with it. So look at ray CB. Ray CB. Is ray BC the opposite ray for CB? No. Okay? Because I would have to, when you name a ray, you always have to start with what? The endpoint. So if I'm talking about ray CB, and I know the opposite ray has to share an endpoint, then I know I have to start with C and go the other way, so it has to be CD. Does that make sense? So I can say that ray CB and ray CD are opposite rays. A set of opposite rays, the first letter has to be the same. If it's not, it doesn't start with the same endpoint. Okay, think about it, let me know. All right, so then we said CB and BC are not opposite rays, right? Oh, I'm sorry. Go ahead, and I want you to draw CB and CD out there so that you can see if you just snapped them together at C, then it just makes that line for you. The C is the endpoint is the only thing that they share. And then we did already say that CB and BC are not opposite rays. Okay, so CB and this type of answer right here is a very common wrong answer. So why do you think if I said, what's the ray opposite of CB, some people would think BC would be the right answer? Right, but why would some people think this is the right answer? Because you're switched, because basically you made them opposite, right? There's more than that. Because that's why I know it can't work, is because when I do that, I'm not starting with the endpoint, and you have to, and they have to share one, so it has to start with the same letter. Do they go in opposite directions? BC and CB? Here's CB, and here's BC. They do, and here they are. Here's CB, and here's BC. The problem is when you snap them together, there's some overlap there because they don't share an endpoint. Okay, yes? Absolutely, yes. BA and BC would be a pair of opposite rays also, yes. No, go ahead. Right, because things live in, like in here I could say, name me a segment, and you could say line segment BC. I could say name this line, you could say line BC. I could say name a ray, and you could say ray BC. So yeah, all those things, they all live in a line, so. Oh no, I would say name a pair of opposite rays. And if that's all it said here, then maybe you put CB and CD, and I would say ray BA and BC, and somebody else would say ray BA and BD, but we'd all be right. Because there's multiple right answers. So yes, but yeah, it'll be obvious what you're looking for. That shouldn't be tricky. You have another question?
Oh yeah. So is there like a thing on the homework like there was on last time saying like identify these, but we don't know if it's a line or an opposite ray like.
Oh, right. So in that case, if I said, if you had to like name this, that's very vague because what is this? You know, am I asking you to name a ray or like, yeah, it'll be more specific, so it'll be clear. Yes. Yeah. Okay. Then postulate. Okay. Now, everything that we've done so far, like opposite rays, there's our definition of opposite rays. It had a ray, we're a definition of a ray. This says postulate. Now, open up and look at the inside real quick. What do all the rest of the words say? Postulate. Okay? That's probably a word that you don't know. But what I want to make sure you understand at this point is what we're about to write right here is not the definition of a postulate. Okay? This is a postulate. But again, you don't know what it is yet. We're actually writing what a postulate is down tomorrow because we don't really have room here. We have a lot of rules in math. Actually, there's a rule for absolutely everything you've ever done mathematically that you've done correctly, even if you didn't realize it and nobody said, hey, this is the rule or there's a rule here. There is. Just like when I showed you those properties when you're solving equations. All those are the reason you get to do what you're doing algebraically. Okay? You need to wait and do that later, sweetheart. So a postulate is just a different kind of rule because we have properties, we have definitions, we have theorems, and we have something that's called a postulate. Now, a theorem is something that I could prove. Okay, so I could, like Pythagorean theorem is something that you're familiar with. I could do a mathematical proof and prove the Pythagorean theorem to you and that it works every single time. There's words that go with it, by the way. Anyway, but I could prove it. With a postulate, you can't prove them, right? They're just accepted statements of fact. The reason we accept them is because, yeah, I can't prove mathematically that it works every single time, but I also can't prove that it doesn't work. And since we can't disprove it or prove it, and it's kind of common sense, and we can all agree, hey, yeah, there's nothing else that would make any sense, we use that and move on, okay? So if I know there's not a lot of extra room on any of this, but if you wanted right above the word or right next to it, I think you have a little bit more room than what it looks like. All it is it's like a rule. It's a math rule, or an accepted statement of fact is the type of rule it is. So this is not the definition of it. We have a few postulates that we're going to talk about that you'll see why they're accepted statements of fact. They're usually kind of obvious, kind of common sense like things. Sometimes it's even like, well, duh, what else could it be? And you might even think, well, that's stupid, I even have to have a rule. Yes, when you start thinking that, instead of thinking, well, it's stupid, I even have to have a rule, just be thankful it's easy and obvious, okay? And just know that there's a rule for everything anyway. So the picture you have, let's make sure that you understand this picture first. This is a kind of poorly drawn picture. Actually, I take that back. I'll get to the picture after I put it up there. I'm going to ask you this. I'm going to put these 2 points, and now my board represents a plane, okay? So these 2 points that I just drew live in this plane. We all agree with that? Okay, so now I'm going to draw a line. I know it won't be completely straight, so you have to pretend. I'm going to draw a line through these 2 points. That's not too bad. So does this line live in this plane? Yes. Would it be possible for me to draw a line through those 2 points and it be anywhere other than in this plane? If the points are on the board, where could I draw the line where they'd go through the points that are on the board? Both of them at the same time. Anywhere? Like if I drew a line out here, then it goes through those 2 points? Right, but these 2 specific points, me drawing a line over here doesn't go through those points, right? If these 2 points are in this plane, when I draw the line, doesn't the line have to be in the plane? Like it couldn't be anywhere else, right? Does that make sense? Kind of obvious? Yeah, that's what your first postulate basically says. Says, if 2 points are in a plane, the line containing them is 2. Because what else could possibly work, right? And then I spared you from drawing the picture that's already not great. Yeah, if 2 points are in it. Yes, because a ray is part of a line. Does that make sense? So that would work for a segment too, because it's part of a line. So technically the postulate takes care of the line, and then because it uses the line, that takes care of everything that lives inside of it too. That's a good question. Say that one more time. Points don't go on for infinity. Lines do, but not points. So I don't understand the question. I have to say it again. Right, but a plane goes on forever, and so does the line. So they both go on forever. It's like no big deal. Yeah. All right, so this picture here, which is, it's kind of poorly drawn, not really on purpose. I mean, I didn't draw it bad on purpose, but I could have made this as part of something else where maybe it made a little bit more sense, but I wanted it to be a random plane. I didn't want it to be a plane that was part of something. So this plane, it's, it has to be 2-dimensional, but this is really a 3-dimensional picture. So this purple plane is like my note card. That red line is like my green pencil. Okay, you see this? So that's why you can't see part of it right here, because it's actually underneath it. That makes sense? Kind of wrap your mind around. You see it now, and that's why it has to look like, it's like that when I'm trying to put it under. Yeah? Okay. So then the green one is actually drawn on the card. The green one actually lives in the plane. The planes go on forever, so it kind of looks like this plane could go on and swallow up the blue lines, right? But the intention of the picture is that they're above and below. Does that make sense to you? Now, when you have to actually identify stuff from this on the homework and whatnot, it will be more clear what things are. I mean, I know I have to explain this one to you in kind of great detail, but that's because I was kind of limited on PowerPoint. But blue is above and below, the green one is actually on it, and then my pencil is the red one that goes through it. You with me on that now? Okay. The only what? Well, no, they're all correct. The only one that, yeah, but the green one is the one that actually identifies to this. Yeah, but all of them we're going to use for the next part over there. So we're going to talk about 3 different ways that a line and a plane intersect. For that to happen and for you to fully wrap your mind around it, we need to make sure that we understand the concept of intersection. Because I think that we kind of have a false sense of what it is, but not because it's, just because of what we usually talk about with intersections. So if I talk about 2 streets, and I have these 2 streets that intersect, right? The intersection of the streets is right here, like where the stoplights are. Yes? Okay. But an intersection of 2 things is not necessarily a passing through. Isn't it possible for streets to meet at a T like this? Yes? This right here is still an intersection. The blue line does not pass through the red one, but I still have an intersection. You with me? If I have this and these 2 streets, neither one of them passes through the other one, but I still have an intersection. The intersection of 2 things is what they have in common or what they share. Because you're going to also look at not just intersections of things, but of sets of numbers eventually. We don't really do that in here, but that is coming for you. So if I have 2 sets of numbers and I want the intersection, well, clearly the numbers aren't going to pass through each other, but it's what the 2 sets of numbers have in common. Okay? And if you have to kind of remind yourself of that, because one of these is a little tricky for some people to wrap their minds around. All right, so the first one says, line passes through the plane. So it's like my pencil through this note card. If the line passes through the plane, what does the line and the plane share? What do they have in common? Yeah, the intersection, but what is the intersection? The point, right? Isn't a line just a bunch of points crammed together? And a plane kind of is too, but the plane has no thickness, right? And neither does the line, so there's just this one point that they have in common where the line actually goes through the plane. Does that make sense? Okay. So if the line passes through the plane, the intersection is a point. That one I think we can kind of, as long as you understand the picture, you can wrap your mind around. So the intersection of the red line and the purple plane is that point right there. All right, so then the next one says the line lies in the plane. So that's like this. So I want you to think without speaking for a minute. That line lies in the plane that is my board. So think without speaking about what would you think that the intersection of that line and that plane would be without speaking. Okay? Raise your hand if you think you want to tell me something. What do you think? The whole line. Okay? Anybody agree with him? Raise your hand if you agree with him. Raise your hand if you don't agree with him, even if you're not sure what it is, but you don't think it's that. And then the rest of you just don't have a clue. Okay, so remember, we think of the intersection as what do the line and the plane have in common? So, do the line and the plane share these 2 points? Yes. Does it share all the points in between them? And all the points on either side of them? Yes. So, does the line and the plane share the entire line? Yes. So then the intersection is the line itself. And that's the one that's a little weird for some people to kind of really grasp. So, if the line lies on the plane, the intersection is a line, because what you're looking for is what do they share? They share everything. They share everything that's on the line. They don't share everything that's on the plane. Everybody okay with that one? That's the one that's a little hard to, it might take a minute to sink in, and then you'll be like, oh, I get it. We might have to come back and revisit that. Okay. You might what? Okay, then the other one, all right. So then the blue lines, if the line is parallel to the plane, they're above and below it, do they have anything in common with the plane? No, they don't share anything, right? So they have no common points. So when you're answering questions like this, if I said, what is the intersection of this line and this plane, whatever they are, you need to, before you try and answer the question, remind yourself, you only have 3 choices for answers. You're either going to name a point, you're going to name a line, or you're going to tell me they don't intersect because there's no common points. You naming a ray, naming a segment, naming anything else makes absolutely no sense. You with me? So you kind of got to learn to answer these questions, and you have like a process of elimination in your brain. What are my choices? I only have 3. I don't get to list points. I don't get to name segments, nothing else. Those are the 3 things that I have. Okay, we good? Any questions? All right, so open this up. All right, what's next? So we have these 2 lines that are on your picture. You already have the picture in front of you. I just can't make it pop up. They intersect, right? What do they intersect at? A point. All right. So is it possible for them to intersect at more than one point? No. Could I say it's going to wrap back around? And no, because it doesn't wrap back around, right? All right. So if I was going to say if 2 lines intersect, they intersect at a point, that's a true statement, but that's not good enough. Because if I have this, okay, so these 2 lines, they intersect at a point. Yes? This line and this parabola, do they intersect at a point? Okay, it's a yes or no question. Do they intersect at a point? Yes, they intersect right here. Do they also intersect at another point? Yes, right here. So if I just say these 2 things intersect at a point, that's a true statement. If that's all I say about this, that leaves the door open for the fact that it could be more than one. Does that make sense to you? So if I said, I have 1 boy in 6th period, is that a true statement? Yeah, he's sitting right there. I also have another one and another one, but you with me? Okay, so in order for me to be more specific and really say what I mean, remember that's what we're trying to get. We've got to say what we really intend to say. I can't just say if 2 lines intersect, they intersect at a point. What could I add to that to make it? Right, that's what I said. Well, when a parabola and a line intersect, they intersect at one point. All lines are straight. I have 1 boy in 6th period. How do I make that a false statement? I only have 1, or I have exactly 1, something like that. That qualifier there. You with me? So if I wanted to say if 2 lines intersect, they intersect at only 1 point, or exactly is usually the word I use. Only is fine though. When you have to explain this stuff and you have to write these postulates or whatever, I usually try and give you as few words as possible and already go ahead and abbreviate. You don't have to spit it back at me word for word, because most likely what I gave you isn't word for word what's in the textbook anyway. Put it in your own words. That's fine. That tells me you understand it and not just repeating words back to me. But you got to make sure all the important words are there. Okay? So if 2 lines intersect, they intersect at exactly 1 point. And notice I'm also not saying 2 lines intersect at exactly 1 point. Because if I have 2 lines, am I guaranteed that they intersect? No, because maybe they don't. But if they do, that's when, get this, if 2 lines intersect, they intersect at exactly 1 point. That word exactly, hugely important. And remember, they're not going to curve back around and intersect again because all lines are straight. We talked about that yesterday. So this is a good place to write it here. All right, so 2 lines intersect. If they intersect at exactly 1 point. What if 2 planes intersect? Now, let's back up a minute. Look at the ceiling. The good example of intersecting lines is the trim that's in between the tiles that are in the ceiling, right? There's lines and they intersect all over the ceiling. So intersecting planes could be like the ceiling and the wall, right? So when these 2 lines intersect, they intersect at a point. When the 2 planes, which would be the ceiling and the wall, when they intersect, at a line. Do I agree with that? Because look at what they have in common. What they have in common is that piece of trim that goes all the way down the wall. Make sense? So here are my 2 planes. When they intersect at how many lines? 1. They intersect at how many lines? How many lines do they intersect at? 1. Do I have 1 boy in 6th period? Yeah. I do, but How many lines do they intersect at? Exactly one. That's why I keep asking you about the boys sitting in 6th period, right? They intersected exactly one line. Now, can they intersect at more than one point? I'm sorry, back up. Can they intersect at more than one line? No, because they can't wrap back around. So these two planes intersect at this one line, because planes don't curve either. Can I make another plane go through that same line? Yes. So now these 3 planes intersect all at the same line. Yes? So could I add another one? Yeah. How many planes can go through this one line? An infinite amount. So 2 planes intersect at exactly one line, but an infinite number of planes can intersect the same line. Do you see that? Another example of how that works and what that is with like a notebook, okay? Each page in here is like a plane, okay? Each one of these is a plane. The spiral is like the line. So all of these planes all intersect at this same line. Make sense? If points A, B, and C are collinear, what does that mean? They're on the same line. So if this is point A, B, and C, they are collinear, right? And so they're on the same line. Every single one of these planes goes through this line. So if I named this plane ABC, well, this also has ABC on it, and so does this one, and so does this one. That's why I can't name a plane with 3 collinear points. Does that make sense to you? Because there's an infinite number of planes that would go through those 3 collinear points. All right. So, but what this one we're getting at here is that if 2 planes intersect, they intersect at exactly one line. And then I spared you from drawing this picture. You're welcome. Now, when you name a plane, remember you can use the italic letter or you could use 3 non-collinear points. The italic letter is the only option I have here because I don't even have 3 points named. You have to use the word plane, but if you're naming more than one, I could say plane B and plane Q, or I can say planes, plural, and then just list them. It makes it easier. So I could say planes Q and B intersect at line XY. Okay. So notice what I'm having you write on your notes is specifically how you would have to answer certain things. You know, planes Q and B, this is line, they intersect at line XY. Right? And then what else we said is that any 3 collinear points have an infinite number of planes through them. And again, I could have drawn a picture where those planes were part of something, because a lot of times they are. We might look at them as sides of a prism or something like that, but they also, you can just think of them as planes that just float around out there somewhere. So 3 collinear points have an infinite number of planes through them. That's why you have to name it with 3 non-collinear points. And there's another kind of reason that goes with it we'll look at in a minute. All right, so the next picture that you have is just 2 points. So I want you to draw a line through that. Your ID badge, by the way, if you just plop it up on the table, that makes a fantastic straight edge that should always be with you. So just draw a line through points X and Y. Now, is it possible for you to draw a different, unique line through those same 2 points? No, because you'd just be drawing right back on top of it, right? And in Algebra 1, I don't remember if we talked about this yesterday or not, but if you, sometimes, especially when you're doing systems, you graphed a line, and then maybe when you went to graph the second line, you graphed it right on top of the first line. Did you really graph a different line, or was it the same line with a different looking equation? It was the same line, okay? So it's the same line. I can make the equations look different, but it's the same line, okay? So what this one says is, through any 2 points, there's exactly one line. That's why when you're plotting points and you know it's a line, you only have to graph 2 of them, and then bam, you got your line. Again, your algebra teacher may have made you do more for good reason, but especially to make sure it's aligned. But you only have to do 2. You don't have to plot 10 just to get your line in there. And then picture. Well, you can, but you don't have to. It's just you only have to have 2. Okay. Now, so are points x and y collinear? Yes. Are points A and B collinear? Yes. Are points A, B, and C collinear? Maybe. We can't say yes and we can't say no because I'd have to see a picture for that one, right? Remember, there are questions you can answer even if I give you a big crazy picture that you don't even have to look at the picture for. Because remember, points A and B, they're collinear. I don't know where they are, but through any 2 points, there's exactly one line, so I know I can draw a line through them. A, B, and C might be, but maybe they're not. I'd have to see the picture or have more information. So any 2 points are collinear. So this through any 2 points is exactly one line. That tells you that you have to have 2 points to determine a unique line. If you pretend like the tip of my finger is a point, then that 1 point can't determine a unique line because I actually have an infinite number of lines that could go through that point. That makes sense? So I put that second point on there and it anchors it down, and that is one line, the only unique line that would actually go through those 2 points. So with that said, do you think, or how many points do you think it takes to determine a unique plane? Could I just use 2? Because if that's 2 creates a line, how many planes could go through that line? An infinite amount, right? So what do you think I need to anchor that down? A third one. But what has to be true about the third one? They have to be non-collinear. Because if they're collinear, I still got the line with an infinite number of planes. Does that make sense? So it takes 3 non-collinear points to determine a unique plane. Okay? That's what you ever sit in a chair, in a desk, or at a table at a restaurant where your chair, your table like wobbles back and forth, and so you're like shoving napkins underneath there so you can stop rocking back and forth and spill somebody's drink. Okay, that's because those 4 points are not coplanar. They can't find a unit. You know, there's like 3's 3 are, but this one's not, so it rocks back and forth. But at any given time, you can set it down sturdy on 3 of them. But then somebody else puts their elbow on the table and it comes back that way, right? So through any 3 non-collinear points, there's exactly one plane. If you are out, if you see a like a photographer or something out there, and they've got their camera on what's that thing called? Tripod, right? And it's not a quadpod because if you had 4, you have the same issue as you do with the chair, and you're out on uneven ground. Those 3 legs of the tripod are gonna find common ground. It may be crooked, but then that's fine. You can just extend one leg and make it straight. Anybody ever been in a barn and milked a cow? Okay. All right. So me either. I've never milked a cow, but I do know that the stools that they use to milk cows are they're 3-legged stools because the ground in the barn is uneven. I mean, it's dirt, right? So even when you sit down on that stool, you might be leaning over a little bit, but you're at least not wobbling because it's going to find that plane even if it's not really what the ground looks like. Okay. So, but a 4-legged something like a chair, it is more sturdy, but that's if one of the little feet don't break off. Okay, but the 3, that gives you your unique plane. All right, so let's look at this point, or let's look at this picture. Remember that I can change the question by a tiny little bit and ask you something completely different. So you got to make sure you listen to the question or read it carefully so you're answering the correct thing. So look at points A, B, and C. A, B, and C. Are A, B, and C coplanar? Yes or no? Yes, they're coplanar, right? Do points A, B, and C determine a unique plane? Yes. Okay, it's the top of the prism, right? All right, so look at points E, J, and H. Are points E, J, and H coplanar? It's a yes or no question. Are points E, J, and H coplanar? What does coplanar mean? On the same plane, right? So are points E, J, and H on the same plane? Yes. So are points E, J, and H coplanar? Yes, they are. How many planes go through E, J, and H? An infinite amount. How many that you can see on the picture? 2, the front and the bottom, right? Do points E, J, and H determine a unique plane? No. Okay, they are coplanar, but they don't determine a unique plane. Those are 2 different questions. Does that make sense? It was both yes for A, B, and C, not both yes for E, J, and H. All right, so look at points A, B, and E. Bless you. Are points A, B, and E coplanar? No. Okay, so reread this. Through any three non-collinear points, there's exactly one plane. So find A, B, and E. Are those three non-collinear points? Do they determine a unique plane then? Yes. So are they coplanar? Yes. Do you even have to look at the picture? Are points X, Y, and Z coplanar? Yes, they are. You don't even know where they are, right? What confuses you about this is the picture, right? But look at this. Maybe. There you go. See that plane? Remember, just because you don't see it doesn't mean it doesn't exist. No, it does not. It's just they're drawn that like that most of the time, but no, it doesn't. Because it actually goes on forever. Oh, yeah, because it goes on. It goes on. But it could be a triangle, but do not name it ABE. I'm sorry. If I name it ABE, don't come in and draw in a triangle because then you're going to think H isn't part of it. Does that make sense? But yes. If it was like a triangular prism or something, yes. All right, so what about points B, C, F, and E? Are they coplanar? Yes. Now, if you want to draw in this orange one, if you just connect A and E and B and H and then shade it in lightly, I'll show you the next one. I wouldn't suggest drawing in the other one too because I think it might be too much on your picture. But here's the other one. All right. And any 3 points are coplanar. So remember that. Any 3, X, Y, and Z, yes, they are coplanar. Do they determine a unique plane? I don't know. I'd have to see if they're non-collinear or not. But those are 2 different questions, being coplanar and determining a unique plane. Oh, dang it. Sorry. All right, here's your homework. Don't walk out without this. Have a great day. I didn't have a chance to ask if you had any questions, so I'll see if you have any questions on Friday. All right, have a great day. Don't forget your homework.